but it should be fine. So, PyData, you can contact us on Twitter, join the Slack. I haven't really deleted this, but there's a bunch of PyDataMCR podcasts which have been lovely. So we've had some wonderful guests, including James, and a bunch of other people. So yeah, please do listen to those and the back catalogues. Get involved in the Slack to have a chat. There's usually some discussion while we have the talk through. But yeah, if you're interested in talking at any future events or getting involved in any way, then do let us know. So your organisers, there's me, myself, John. There is Joe, who is very kindly at home handling the streaming. So he's doing his job very well, even though you can't see him. We've got Shaun, who is an organiser, and we'll also be talking. And we've got Jennifer, who unfortunately couldn't make it this evening, but is still a very valuable part of the team, and we miss her today. So yeah, any of us, you want to get in contact with any PyData things, then please do give us a shout. If you want to get in contact with any of us, if you look at the Twitter for PyData Manchester, we're all linked on there. Obviously, just talk to us as well. So we got a code of conduct that is very important, and again, I want to emphasise this because it is the first in-person meetup for a couple of years. PyData is a professional event, and while it is here for us to learn and have fun, it is important that we all do maintain professional conduct. Basically, don't be rude. There is more details about this online, but if there's any issues anyone has, then please do get in contact with us so we can take action. And we've got an anonymous support form just in case you want to stay anonymous while you do that. But yeah, I do want to emphasise, do try and maintain good standard of conduct. So one thing we try and do with PyData is if anyone's got a job, then please do shout out so we can share it, make sure that anyone who's looking, and if you're looking for a job, then do shout out, we can make sure the two people meet. Because I know I found jobs through PyData, I know lots of other people have, so it's lovely to keep the networking and communication going. If you organise a meetup, want to shout out a meetup or any other kind of event in Manchester, then again, let us know. This is your chance. N Brown. We'll all get it back in that.
Yeah, so I'm from Jordan, and I work for Manchester United Football Club. The jobs aren't online yet. Hopefully, in the next 2 weeks, I'll have several jobs available, which range from data engineering through machine learning scientists through sort of excels at precision science. So if you're interested in that kind of thing, working on football club, then
how can people get in contact with you?
How would you get in contact with me?
Yes.
Through LinkedIn, yeah.
Through LinkedIn.
Cool, yeah. No, I'm not sure then, but I get a lot of LinkedIn requests, so say you know.
Yeah. Yeah.
John, you probably just want to repeat that because
Very good. Very good shout, Anne. Thank you. Yes. So, as Dom has said, Dom and Fiona said, for the benefit of people on YouTube, there are jobs available coming up at N Brown and at Manchester United. So speak to Fiona or Dom, respectively, on LinkedIn. Behind Dom and Fiona. I'm sorry, I don't know your name.
So if anybody is wanting to come over to that side or from Leeds, we work for a business called the Data Shed, also looking for data engineers, permanent and contract. And same as before, contact me via LinkedIn.
Cool. Thank you very much. Excellent work. Anyone else? Cool. Well, thank you very much. What have we got? So yeah, thank you very much for our sponsors. So NumFocus are globally support PyData, both in terms of meetups, conferences, and a lot of the open source software that I'm sure you know and love, like Pandas. Thank you very much as well to Infinity Works for hosting us, for the lovely venue and the lovely food. There'll be a moment of housekeeping after this. We've got talks from Shaun, from Fiona. It's there. Afterwards, we'll be popping down to Hatch, which is round the corner, nearby. So yeah, contact us. Thank you very much.
So just really the housekeeping, a little bit late, but just we don't have any alarms planned. So if the fire alarm goes off, we're to follow the fire wardens who will get us safely out of the building. And I know a couple of people already asked, but toilets are sort of opposite where you came in on the other side. So if you just go out the way you came in, Paul will let you out and back in again, so you can come there. But yeah, we're really pleased to be able to host PyData Manchester. So Infinity Works, part of Accenture, are based in this building here. So it's really nice to have in-person events back in the building, and I'm glad that the food was a success. We had a lot of chats internally about that. And then just a couple of things that I wanted to mention. We're running a GCP BigQuery workshop next Thursday, the 7th of July, between 4 and 6, if anybody's interested in that. And I'll put the link for that into the meetup. And then, and Twitter as well. Yeah, I'll do that. And then the other thing, with a completely non-Infinity Works hat on, I'm also involved in a PyCon UK organisation. So the call for proposals closes on Saturday at 5 p.m. If anybody would like to join the rush in the last 48 hours, you've got till Saturday to do that. And the conference will be 16th to 18th of September in Cardiff City Hall. So. And that was really all I was going to say. I'll pass the floor back over to you.
Thank you very much. So without further ado, Shaun.
Right, hello. I'm assuming this is still on and you can all hear me. Cool, I've seen some nods in the back. So I'm going to be talking about topics, classification and reviews. So this is a topic a little bit close to my heart. So I'm currently, a little bit about me. So I'm Shaun, as John so kindly introduced me earlier. I recently started a job doing data science at a company called Daily Feed, who specialise in kind of social media marketing. I'm just finishing off an MSc in data analytics at Glasgow, which is why this is a subject so close to my heart, because it happens to be my dissertation topic as well. So yeah, you can reach me on Shaun Hyde1 on Twitter, but without further ado, let's jump into it. So all of us have worked in the industry for varying lengths of time, and I don't know about you, but my experience of text data in the industry has been interesting, shall we say. Text data is fairly ubiquitous, so it is pretty much everywhere. Even if you think it's a business that doesn't have any text data, I guarantee you there is something somewhere. And most commonly, I would say that typically comes in the form of reviews. Even if it's just a Google review for your business, which may or may not be what you want to see. This text data is often underutilized. So a lot of us are quantitative in some way, so we like looking at summary statistics. Realistically, text data is often quite hard to summarize in such a simple format. I've seen a lot of examples where possibly people who aren't as familiar with analytical techniques typically use sampling. So we could have tens of thousands of reviews. All of the review text, they may look at the top 10 or kind of the most influential 10 of those to try and make any kind of inference. And obviously you miss out on a lot of data in that regard. But it's not all so bleak. The great news is that the tooling has evolved and is evolving to empower not just the analytical side of things, but also any of the data users. Some of the open source tooling for text data has made this much easier for us to do. And I'm going to dive a little bit today into kind of, if we were to try and approach a problem from a text data perspective, how we might want to approach that. So the problem statement. So my favorite, ratings or reviews. So obviously they've typically got two components. So a rating, so typically between 1 and 5, i.e. the summary statistic that we like to rely on, and then text, so the information to back it up. And there's three bog standard reviews. The top one's from a local gym, the middle one's from McDonald's, and the bottom one is unfortunately from an ISP in this country. No guesses as to which. The issue with these reviews is that, you know, ratings are easy to fake, and what you guys will see, or probably have seen in the news, is that the government is increasingly trying to legislate against fake reviews. But there's a good question as to how do we get around that. Ratings are also uninformative. So I say that because what's the difference between a 4 and a 5? Nobody can really tell you what that difference is. And actually, if you do look at reviews, more often than not, they're biased towards the 5 end or they're biased towards the 1 end. So typically you might get an average somewhere between the two, and that's actually not very useful as a consumer. Comes back to the element that they're biased as well. Interestingly, when you look at research around ratings, if people see a company that only has 5-star ratings, they actually trust that rating less because they believe it doesn't reflect the truth. And I know all of us have been to places with TripAdvisor saying, give us the best rating you can. You know, ratings are biased from both the person giving the rating as well as the business requesting the rating. And ultimately, more often than not, there are too many reviews to read or too few of value. So, there's two elements that I want to look at. So, how well can we approximate the review rating using the review text, i.e. a classification task? And secondly to that, can we categorize reviews to help improve relevance, i.e. topic modeling of some description? So I'll just dive into each of those separately. So let's start with looking at the data. So a nice toy data set of movie reviews from the NLTK library in Python. As you can see there, the number of documents is 2,000, and we've got a tokenized review supplied and a class, so either negative or positive. In this case, they're all negative, but you know, further down the list, they do turn positive, trust me. So of these 2,000 documents, broadly split, 50-50, so 1,000 into the negative, 1,000 into the positive. Nothing too exciting there. The only thing that we know there, it's a balanced data set, so we're always on to a bit of a winner in that case. Interestingly, so in this data set, the median positive review tends to be slightly longer. So a lot of these reviews, I think in this data set, are professional movie critics reviewing. Don't think this always plays out, but when you look at other review data, often it's quite sort of polar. You get either the people singing the praises of the company you're talking about, or the complete opposite, where they'll give you the longest piece of literature you've ever read, explicitly spelling out why this is the worst company you've ever encountered in your life. And whilst they do make for good reading, it doesn't always necessarily add that much to the argument. So, how does one kind of approach and prepare text data? So, there's probably no surprise. As it turns out, computers can't really read, which is unfortunate because it'd be quite useful. So first of all, we need to remove stuff that confuses a computer. So that is stuff like punctuation, stop words, so really common words like and the. We then need to do some kind of truncation of the words. So in this case, I've chosen lemmatization. So that means essentially truncating the word to get rid of the ending, but keeping it as a real word. So from running, for example, it would swap to run. And then similarly, tokenization, so splitting that text into smaller tokens, so typically words in this case. We then have to do vectorization. So as I said, computers can't read. So we have two options in this space, and there is a kind of a semantic unaware version, and that is typically taking a document, so in this case, the review that I referred to, and doing something like a word count. So, you know, for each unique word in the vocabulary, you will create a new column, and then that will just have the frequency by document. Now, as you might expect, the dimensions of that gets very big very quickly. A slight variant of that, so term frequency inverse document frequency, which is a bit of a mouthful, so it's TF-IDF from now on, where essentially it just normalizes that view. And then there's a kind of semantic aware view, and that is something like doc to vec. Which we'll dive a bit more into, but essentially it takes the paragraph, or the document in this case, and represents it in a a lower dimensional space than you could achieve through kind of a semantic unaware, but it is also aware of kind of the context rather than just kind of a raw word count or a transform of that. So TF-IDF has broadly got two components, so term frequency. So it is as simple as the number of words times a word appears in the document divided by the number of words in the document. So, you know, in the example, the brown cat sat on the mat, the occurs twice, so it's 2 over 7 because there's 7 words. Inverse document frequency, on the other hand, this looks at number of documents as a numerator and the number of documents containing the word. So if we added another document to that list, so hello world, classic, and we calculate the IDF of there's 2 documents of which it appears in 1. Realistically, we often log transform this as well to normalize the range of IDF. Otherwise, if you have, you know, a lot of documents, it gets very, very big very quickly. TF-IDF is then just quite simply the multiplication of the 2. What essentially this achieves is that words that are more unique to each document are up-weighted versus words that are common to all documents. And this is quite useful for then teasing out extra details. Now, Doc2Vec, for those of you who have encountered Word2Vec, it's essentially, as I said, representing a document in a higher dimensional space, but trying to retain the semantic meaning of whatever the document or word is. And, you know, in this case, we'll dive into a bit more, but there are 2 main variants. There's a paragraph vector distributed memory example, and this is where you train the document vector at the same time as the other word vectors. So essentially it supplies a bit of the ingredient to making, to trying to predict the next word in the sequence. And you can see that you do an average or concatenation across the paragraph plus the words. The slight variation is the paragraph vector distributed bag of words, where essentially what we're trying to do is predict the paragraph, predict the words in the paragraph from the paragraph vector itself. As pointed out by the authors, you know, the paragraph vector distributed memory, or PVDM, is usually sufficient, but actually to get better performance, you typically combine both of those approaches. So how do we do this? So it'd be remiss to not include some code. It's fairly easy to do TF-IDF vectorization in sklearn. You can just pull the vectorizer down and then do a fit transform on your data. In this example, so in the movie example, I split into trained test sets, and on my training set, you can see that the dimensions of that output was 1,405 by 32,000. So it's a very, very large matrix, essentially. The advantage of this is, you know, it's pretty concrete. It's very easy for us to interpret that. But it is very high dimensions, and you can have issues related to that when you want to do something next. Doc2Vec, a little bit harder to do, a bit more verbose code-wise, but broadly, you import GenSim, so there's a great library called GenSim that allows you to do a lot of more convoluted techniques, I suppose, in NLP. You prepare your corpus, so it expects tagged documents when it runs the model. You then define your model. So in this case, I just chose a vector size of 128. Typically, you're looking for some multiple of 2. Min count allows me to control what the minimum frequency a word has to have before it's considered. Epochs is essentially the number of times it tries to iterate through those that vector to refine it. And then you build your vocabulary, and then you train your model. What this has done, so to the point of the paper saying that we should have both DM and distributed bag of words, you can see that the dimensions of this output is actually 1405, so the same length as training data, but twice the number of vectors that, twice the width that I specified in the vector size, because I actually trained it twice. One with DM equals 1, one with DM equals 0. The advantage of this is that significantly lower dimensionality. Disadvantage, obviously, it's a very abstract representation of data. It's not, you know, to a human, it's not very interpretable, but it's extremely useful from a sort of computer point of view, shall we say. So, on the classification task, as I kind of specify, the train and test set was split 70-30. I used a support vector machine. So again, this is from sklearn, everybody's favorite library. Classifier was measuring accuracy, just to see how it did. And we looked at the performance in the test set. So what I found, the TF-IDF vector had a test accuracy of 83.1, which, is pretty good, all things considered. What I then did was split out the doc-to-vec vectors into kind of PVDM by itself, PV, the distributed bag of words, by itself, and then the combination of both. And you can see there's a slight performance drop-off when I combine both, but it should theoretically be slightly more robust going forwards. Analysis at LSA, which is kind of a variant of principal component analysis, or latent, I'm going to say this wrong, but Dirichlet allocation, or LDA. What the great thing that's happened since kind of this embedding approach is that more recently there's a newer version called topic to vec, or top to vec, which is actually built in this doc to vec paradigm. So, we still do the same thing as we did previously. So we map our documents into a vector space using the PV distributed bag of words approach. And you can see a rough diagram on the right-hand side there. What we then do is we do dimensionality reduction. So in this case, the algorithm uses UMAP. I can't remember what the acronym stands for, but to all intents and purposes, it reduces the dimensions of the 100, whatever the vector size is, down considerably. And then finally, another lovely acronym that I can't remember what it means. Essentially, this then looks at that condensed vector space and tries to identify clusters of high density. So the image on the far right there, you can see kind of the hot spots. Our data's not as exciting as that, but essentially that's what we've applied to this data. So again, relatively straightforward. You do a pip install, because apparently I didn't have it in my Google Colab when I did this. It's actually very light code light, so you just specify kind of your model, supply your documents in a list form. It automatically detects the number of topics, and then for each of those topics, in this case, I generated a word cloud to kind of show what that means. So in this data, there were actually only 3 topics that came out. So the top right, so topic 0, didn't really tell us much, and that's because it seemed to be everything else. So if any of you have ever done clustering before, you typically have this kind of problem where you have some highly specified things that you can clearly identify, and then just a bucket for everything else. The middle one, I like to call this horror genre. I think a lot of the reviews are from the late 90s, as far as I could work out. So Blade is obviously featuring quite keenly there. And then finally, the bottom one, Phantom Menace, Jedi, Lucas, obviously Star Wars. What I will say though, given the similarity of all these text sources and the size of the content, 2,000 records, top to vec actually struggled to differentiate sufficiently with this. But there are certainly tweaks that we can make in that regard. I guess I figured I'd leave an option for people to have a play themselves if they're interested in this kind of thing. So I've got a Colab notebook, and I'll share the link in this deck afterwards for the classification task. And I've also got the topic modeling as a Colab notebook. So if anybody wants to have a play, have a go, you can go there and have a go. And that's pretty much it. So if there are any questions, happy to take them. Thanks. Go for it.
Let me just bring you this, because then the people online can also.
Thank you. So you mentioned this tool, something like HDBS or HDB scan,
Yep.
for reducing dimensionality. So it looks like it reduced dimensionality to 2 dimensions.
Mm-hmm.
I assume it looks very different from, let's say, different points of view. So is there a way you can specify, or this is the only one you can get? In sense, you can say what are you focused on, what you're interested in.
Yeah, so from my understanding in the top-to-vec implementation that's currently available, I don't think there's too much customization in that regard. That being said, you could take individually some of those techniques out of the box, so to speak. So, GenSim has the doc-to-vec already implemented. There are open source implementations of UMAP and dbScan, so I'm sure you could make tweaks in that regard. But as I understand it out of the box, it's not that sort of changeable, unfortunately.
Okay, sort of one quick, can it go to 3D or it's only 2D?
I think in the implementation they have, it's currently 2D. I don't actually know if you can go 3D. Apologies.
Yeah, thank you.
Right.
Thank you, Shaun. Good talk. So, excuse me. You mentioned at the end the clustering method was hard to differentiate between different clusters. How would you go about measuring that?
So in the case, the reason why I detected that they weren't that differentiable, there were 3 clusters and they weren't very well distributed. So, there was that all other cluster that had, probably 80% of the records in. I think in reality, the best way of kind of addressing that is to get a larger corpus. Now, there are kind of options in the top-to-vec space, so you can kind of include pre-trained embeddings. But realistically, in the case of this dataset, because it's quite specialized, it didn't help that much either. So there's still some exploration to do in that space. But yeah, that's kind of what I found.
Are there any kind of automated measurements or metrics that you can use? I mean, I realize it's an unsupervised problem, so it definitely is tricky to have any kind of metrics. But
yeah, so I think I assume it would be quite subject to a lot of other like clustering type measurements, so like intra-cluster distance and inter-cluster distance as well. So those would be other metrics that you could then check, how valid your clusters are as well.
Cool. Thanks, Shaun.
I've got a horrifying data engineering question for you. Obviously, it's very loud, isn't it? Text classification like this is more useful the bigger the corpus, as you just said. So how well would this sort of scale up if you did have a really big corpus, and can you distribute it in any way, or is it just something that's going to be local?
Yeah, so that's a good question, and that was one of the first problems I ran into, is it's extremely computationally intensive. Realistically, so there's a distributed version of certainly GenSim doc-to-vec, so you can leverage that. There are some other tricks that you can do. So as you saw there, kind of I iterated the number of cores, etc. But there are distributed mechanisms to do it as well. But yes, that was my first problem I had to tackle. So it's a great question.
Absolutely.
Right.
Cool. One more question. Excellent.
For topic modeling, can you use RNN or some kind of LSTM network?
Yeah. So there are a lot of other options. So not just kind of top-to-vec. Once you get to the point that you've vector represented your data, the world kind of opens up to you in terms of, how do you then want to apply an unsupervised learning algorithm over the top? You could do something as simple as like k-means, but as long as whatever algorithm you're trying to apply can work with unsupervised learning, then the world's your oyster, so to speak.
Basically, pre-processed to build a back of word models, then do word embeddings and use autoencoders to reduce the dimensionality and then come up with the clusters.
Yeah, so definitely possible. And certainly if you wanted to take a more directed approach, if you wanted to have a more specific sort of, like if you knew what topics you had in mind that you wanted to shape it towards, that would also help. Obviously in a lot of text problems, it's more mining than it is kind of, these are the topics I have in mind, but certainly you could do that as well.
And would n-gram analysis also would help in this approach?
Yeah, so that was kind of an evolution of when you kind of move away from just a plain sort of word count, like bag of words. N-grams are kind of an evolution of that, and that's kind of where your words vec, etc., came from, is trying to address the fact that a word context is as important as the word itself, which is lost in the kind of non-semantic, I guess, count type models. But n-grams is kind of a route to solve, at least partially solve that, certainly.
Okay, thank you very much.
Thank you. And thank you, Shaun. Great talk. Next up, we've got Fiona.
Weird holding a microphone. I think you can see me on the camera there. Cool. Okay, so hi everyone. So yeah, today I'll be presenting my Bindicator project. I'm going to look at that might be easier to kind of see where we're at. Be presenting my what I call the Bindicator project, which is a sort of Raspberry Pi Python combination to make a fun device, basically. Oh my goodness, that is not what I expected. This working? Yeah. So yeah, just a quick introduction. So who am I? So I'm Fiona Pye. I'm a decision scientist at Brown. My kind of background is originally actually from geoscience, so kind of very different. I did a master's in paleontology, and this is where I kind of really got into coding and how I moved kind of into the sort of more data science world. But yeah, so you can find me on Twitter, and that's me on LinkedIn as well if you're interested in connecting. But yeah, so yeah, generally just like, you know, learning about tech and just playing kind of with data. So first question you've probably all got is, what even is a Bindicator? It's not an original idea. It was invented by a guy from Glasgow. I think he either tweeted about it or it was in the Metro or something in about 2018. Basically, it's a device that checks the council websites and lights up in the colours of the bins that you need to put out so that they're collected the next day. It's kind of simple, but like it's something that doesn't really exist. And my sister said to me, if you're going to make something with your Raspberry Pi, you've got to make something that doesn't already exist or you're wasting your time. And I think this definitely falls into that category. So this guy at Tarbard is the one who actually made the original Bindicator to put credit where credit's due. So my Bindicator is built with a Raspberry Pi in Python. It looks a bit jankier than his sort of nicely kind of designed. He's got like a sort of bin-shaped thing. Mine's a bunch of lights in a box and some cables, but it does work. So the functionality that we have is we have this set of lights that kind of light up. It also does push notifications. So if you're not in the house, you're not in the room. I've also got kind of multiple users set up. So if you don't have a light device like a Raspberry Pi in your room, it like sends text to my uncle so he knows to put the bins out as well. And that's kind of us testing out to see what's going on. You can see this is the push notification that you actually get from the device. So yeah, go complete beginning in case people haven't come across them. So what even is a Raspberry Pi? They're tiny little computers. They're about kind of this big. They're kind of like an Arduino if you're familiar with these, but they're a little bit more developed. They've got like a proper kind of operating system. You can plug in a screen and kind of play with them. They kind of have a Linux-based operating system. It's called Raspberry. It's kind of like a cut-down Debian, I think. But they're really popular for kind of Internet of Things devices, for training in like computer science, building little robots. You know, there's kind of loads you can do with them. And this is the Raspberry Pi website, and they've got absolutely loads on there. I actually love the Raspberry Pi website for its explanation of Git. It uses like this Harry Potter example that I just love. but it just is a really nice way to like learn about electronics and programming. So basically, this is to run through kind of how the Bindicator works. So it's all written in Python 3, and I've got here a screenshot of all the packages that I've used in this Bindicator code to give you an idea of what's going on. So you've got the kind of date and time stuff, because obviously we want to know, you know, which day do the bins need to go out. We've got this JSON package around like reading all this config data. So I've got like different users, and this is all managed through different JSON files. I've got all this system stuff. So obviously I develop largely on my laptop, which is actually Windows, and then you have to kind of move over to the Raspberry Pi, which is a kind of Linuxy system. I use requests and LXML, HTML for kind of the web scraping. The push notifications, I use like an app, but it's connects kind of through these two packages here. And Blinked is the package that comes with the lights that I bought, basically. So they kind of done all the hard work for me on that one. So what I'm going to kind of run through with the Bindicator today is a bit about the kind of automated scheduling that I've done to kind of make sure that it is checking the website for us, a little brief introduction to web scraping, and then also like how I did my web scraping, kind of a bit about how the lights work, the push notifications, and then just a bit about kind of what it's like when it kind of works, and then a brief like summary of the kind of tech that's kind of behind it. So we've got this slightly chaotic slide, but basically I have a Git repository that I develop in, and I've shared this between my Raspberry Pi and my computer, and that's how I kind of like move between the two. The first thing that kind of, you know, needs to be running for it to work is to actually schedule your checking of the website. So I've done this by kind of automating it using cron on the Raspberry Pi. So yeah, kind of added this like thing at the start of the script so that it'll run. And then this means that once you add this, I think it's called a shebang, it means that you can then run your Raspberry Pi to actually run that Python script through the terminal. And this is basically a scheduler. So cron jobs is like, I think it's the same as like Windows scheduler. You can basically just set up like automated tasks to do at a particular time of day, a particular day of the week, etc. So you access it using the sudo cron tab -e, and then you can just like set up using these config. You add in different numbers here, and that kind of tells it what to do. I've put a link on kind of to some resources that I use to work this out. And basically this checks it like every day at like 7 o'clock to see if the bins need to go out, basically. So kind of the little introduction to web scraping. So the web scraping, yeah, this here was, you imagine it as this big data mining thing, but what I've done here is more like bucket and spade. It's very basic kind of introduction, but it works. So yeah, what is web scraping? It's like an automated process to kind of go out and find data from websites and kind of extract it. It's often kind of like text data, as you were kind of previously discussing. So you're kind of just going through, in this example, the HTML of a website to pull out what information you kind of want. There are lots of protection around these kind of like bots on websites. I have had problems with reCAPTCHA, which, you know, it kind of, if it detects you're doing this kind of automated behavior, it can stop you and be like, oh, you're a robot, and you're like, I actually am today, for like that one time ever. But yeah, with HTML, kind of you have like on your web page in the background, all the data that's on that web page is like stored in this kind of big text structure. So it's really easy to access that data. JavaScript is much harder to do, and I think you often have to kind of simulate a user to get the data triggered, so if you want to extract it. So luckily for me, my counsel is HTML. I've since discovered that a lot of other counsels are actually JavaScript, so I need to up my game if I'm going to kind of diversify this. So with, I live in St Helens, this isn't my address in case anyone was wondering. I thought of that one ahead of time. But basically you can see that we have the recycling bin, the green bin and the brown bin, and you get all these collection dates in a lovely table. So this is basically where we want to pull our data from. I think I did this in Chrome. You do like right click and inspect, and it'll open up this panel at the side, which is where kind of all of your HTML for your document is stored. And very handily, it'll actually highlight the section as you kind of hover over it. So if you're looking for that data, the best way to find where it is in here is to kind of scroll down. It tends to be hierarchical, so it kind of comes in and in. It'll be like the whole page and then sections of the page as you move down, so you can find what you're looking for. What I've used is XPath to actually extract these, which is just kind of a pointer to a location within this HTML. I did look up what XPath is. It's a query language for selecting nodes from an XML document. So I guess HTML websites are kind of types of XML document. But yeah, so the important thing for us is thinking, you know, when's the next day for each of these different types of bins? That's kind of what we're looking for. So the important thing is that we pull out that XPath, which in here is located here. So you just kind of pull that out basically. So here's some code where it's basically showing you the different functions that actually kind of do that web scraping. So the first thing is we just literally get all that HTML kind of as a text string, pulling out kind of those particular bin days. And then the next thing we do, so this is kind of within this function here, you can just work through it and kind of pull all the dates that we want. And I do some like all the kind of, you know, is this a valid date kind of things. I had problems with like, you know, random stuff happening. So it's nothing like a bit of quality testing. And then basically the date is originally coming in as like a string. But then I've got this bit here to kind of turn it into a timestamp so that I can go, is this bin day tomorrow? Because obviously you put your bins out the day before, and that's the comparison we need to do. And if you do want to put it out tomorrow, then we kind of compile together this like which day of the week is the bin day, etc. And then you can basically return this out to your users and kind of use it for setting up your lights. So that's how that data is kind of extracted and processed. So the lights, I've got a video of actually working here. So I've got a bunch of settings depending on which bin combinations the council put out. So you've got brown for the brown bin, green for the green bin. And then I've got like a set of combinations depending on if they, you know, do the recycling is multicolored, which is quite exciting. So it's like recycling and green. So it's all these different processes. And this is like a demo function where it'll run through all the configurations of the lights. That I kind of set up. The light structure, so like which light is which colour, again, that's all stored in JSON that you kind of read in. But yeah, so you can kind of see how it works. It's very bright actually, but yeah, quite cool. So the function behind this, basically, I've got one where it lights up like one LED at a time, say if you wanted to set different colours, but then also I've got one that kind of will do them all in the same colour for kind of efficiency. So the RGB is all for like each of the light colours. You put those colour codes into the JSON to say, okay, this is a green light. It will then look that up and put that in if it's a green bin that's come out of that data structure that we scraped from the website. Sometimes there's two bins out on the same day. That's quite a common thing where I live. But I've got functions for like 1, 2, and 3. And basically we look for like the different bin combinations that have come up as actually being matched as tomorrow, and then I'll combine together kind of, you know, the different lights that you need. So it'll just kind of look for these settings and then put them all in. There's probably a more efficient way to write this. But this was actually me learning how to write functions originally. So it's probably not the cleanest code. So yeah, you light up all your lights as I kind of showed in that previous demo. And then at the end, I think they stay on for like 15 minutes. And then this LED's off, we'll just like clear it so that it kind of shuts down again. So the push notifications, I've used an app called Pushover, which you basically register for. I think it's, yeah, there's a 30-day free trial, or then it's £5 for like a lifetime license for a particular platform, which I thought was quite a good deal for the amount of playing you get to do with it. This came because my uncle was super jealous that we always knew what bin date was, and he kept texting me to ask me what the Bindicator had said. So I said, right, I'll put you on it as well. So yeah, it just sends you these texts. When it's checked the website, it'll compile these messages and send them out to the different users. So the way that Pushover works is it basically gives you access to like a REST API, and you can just transfer messages between devices using different keys. So how this works is basically we've kind of looked up on the website what the bin combinations are and what the colours are and what day it is. And basically we just generate a message that is the actual text that it sends. So we go, okay, well, who are we wanting to send this message to? So it like iterates through my different users, and it'll say, right, so for Fiona, it's the brown bin day, in which case we want to create a push message that says, okay, the brown bin's going out, etc. today, and that's like it compiling for each different like kind of version. So you go, you know, we've got 1 bin, 2 bin, 3 bins, etc. And basically this is then sent to this Pushover. So here we just connect to the API that is that app, and then the kind of keys between the user and the Bindicator app. So the Bindicator app always has its same API key, but you put different ones in, and then it'll basically just compile that messages and then send it straight over to our users when it is that particular bin day. So yeah, result and process from all of this together means that every day, each of my users, will check the website, and it will only light up or send texts if it's a bin day tomorrow, and it'll tell you which bins it is for. So you can see here, we've got this one saying it's, you know, recycling and bins, recycling and green to go out, and you'll get this kind of light up. It sits under my parents' TV, and they absolutely love it whenever it lights up. And if I don't have it on, they miss the bin day completely. They've become completely dependent. So yeah, the tech kind of behind this, I just Googled a lot of it to work out how to do this. But my Raspberry Pi is a Raspberry Pi Zero W. A bit about the cron jobs, Python, you know, kind of I've mentioned Git. It's all available on GitHub for free. If anybody wants to kind of take it and have a look, have a play, make your own, just go for it. The lights is Blinked from Pye. They're like a UK-based kind of Raspberry Pi and other tech website. They've got loads of stuff. But they developed the package and made the lights, which made my life a lot easier than having to like do it with like raw LEDs. I don't even know how you'd do that. And then here's a link to the pushover app that I've kind of run through as well. So yeah, plans for the future. I want to add Nosy Council where my boyfriend lives, but it is JavaScript, so there's a steep learning curve on that one. And then also my uncle complained that I send the messages like too late, so I'll have to work out how to split that out as well. There's nothing like having fussy customers. And then, yeah, I've been learning a lot of work around kind of different kind of tech stuff and like improving my code, because obviously this was me learning functions in the first place. So thinking about how I can make this better around documentation with doc strings, you know, thinking about unit tests or like writing classes where appropriate, just to kind of, you know, improve my skills, because that was the whole point of this project in the first place. Yeah, kind of shout out, as I kind of mentioned before, we've got a whole load of roles going across like a whole level of like grades and different kind of disciplines within data. So just come and have a chat if you're interested. And this is the M Brown website where they're all advertised as well, if you are looking. So yeah, that's everything. Does anybody have any questions? Thank you. Hiya. Do you want a microphone?
Thanks, Fiona. Yes, questions?
Just a quick one. Have you considered using Selenium for your HTML screen?
Yes,
grubbing?
I have. I've thought about it and vaguely started, but I haven't actually got anywhere with it yet. Yeah, that's my plan. I think the hard thing, well, I haven't tried. The hard thing I realised was I've used Selenium once, where you like search Google by writing in a phrase, but I have to pick from a drop-down list, and I haven't worked out how to do that yet. And that was literally the point at which I got stuck at, because like I ran out of time that day. But yeah, this is definitely the way to go. But that's quite a big upgrade, really. Yeah. Yeah. Oh no. You got a mean one.
Yeah, just kidding. So I'm mainly interested in these push notifications.
Yeah.
Can you say a bit more about it? What can we do, and what type of message can we send?
So basically, you register, and you have a bunch of different settings. So your app itself will have like a key, but then you can also develop keys for apps, and then also there's like another one as well. So if I have pushover and you have pushover, I can actually send you messages if you give me your key. And with my uncle, we're sort of cheating a bit and using the same account, but I've just enabled my pushover on his phone basically. But obviously you wouldn't do that with like everyone. So yeah, it's really useful. It's like quite an easy and intuitive thing, and they have good introductions. I haven't really like pushed it to its limit. I think if you're on the free version, it's like 30 days or like 50,000 messages or something. And after this, it might cut your free trial short. I think there might be a limit on the £5 one before they might have like an enterprise level. But I feel like it is a ridiculous amount of messages you'd have to send before you'd reach that. I don't know what else you're kind of looking for with this, but I can kind of send you the website.
Okay, well, it's now just see what is possible.
Yeah, I mean, you can just build kind of messages. I haven't come across any limits on like text length or anything like this. And I think you can add like as many users, like if other people have it, you can add as many users as you want. I don't think there's a restriction on this, but yeah.
Okay, thanks.
Yeah, no worries.
Yeah. Sorry. I'd just like to say, for first, I think all of us Google things all the time, so great learning there. It's amazing. It was pretty approachable as well. It was really nice to see your presentation. Thank you for that. Another thing is I did a similar project some time ago, web scraping wise, and along with Selenium, that probably would have solved my problem back then. Another one that got thrown at me back then was API. Basically, to query the API directly, it probably will reduce a lot of
Okay.
the overhead.
Yeah. I guess it was finding it. Someone did mention around looking for that council API, but I've got no idea how you'd find that, to be honest. I did Google nosy council API. That didn't turn up with anything. But yeah, no, if it's out there, that would make a big difference. Yeah, thanks.
Nice work, thank you. So first question is, where did you deploy this application, the Python application?
It's on the Raspberry Pi. So like the Python script, like I transferred it using Git over to the Raspberry Pi. And then because it sits in a folder on the Raspberry Pi, the cron jobs looks to that location and runs it, if that makes sense.
Makes sense, thank
Yeah,
you.
no worries.
Hi. Just for the API part, I think you can use the same inspect thing and just go to network and see if there's, that can be helpful actually, because working with scraping and all, if there are API calls coming in, if simple get calls, it'll just save you a lot of time.
Okay, cool.
If you get lucky.
Yeah.
I mean, sometimes it's just static content, then you have to do scraping.
Yeah.
And in terms of deployment, I think if you look into deploying it on a server or something and using the Raspberry Pi same as receiving notifications,
Okay.
that could open up some windows as well.
Yeah. Okay, cool. Thank you.
Yeah.
Thank you. We got any other questions? Anyone else? No? Okay. Well, thank you very much, Fiona.
No
It's really
worries.
useful.
No.
Are you able to share your slides?
Yeah, of course.
Cool. We'll try and get them online. Shaun, are you able to share your slides? We'll try and put them online as well. So yeah, thank you very much. We're going to head down to Hatch, which is and then out the main road and down past Tesco. It's dead near. It's obvious. It's fine. Again, if anyone's looking for a job or interested in anything like that, then Fiona, Dom. Sorry, I forgot your name at the back. Adam from DataShed as well, or speak to myself, Shaun, and we can try and put you in touch with anyone. But thank you very much, everyone, for coming down. It's been lovely. Make sure to eat the rest of the food.